Okay, for the case of two-dimensional array, it is a bit different compared to one-dimensional, where only one dimension is only one line. For the two-dimensional array, it contains a certain numbers of rows and columns of the elements. So here you can see that the definitions or the declarations of the defined constant would be more than one. For example, here you want to define and store a 3 by 3 matrix in the raw major order, right? So what you can do is you can do the what you call that, the easy 68k, and you can see here the defined constant 618, and then the second row is defined constant again byte. This is the size 753, and defined constant of byte 294. So here you can see the difference on the what you call that, the rows and the columns. So how is it divided? So here is the part of the column here, right? You can see here is the one, right? Row will be this one. Will be the row, and the column will be from here. So for this case, we are going to create an array named magic square. So this is just an example. You can just put any names that you want, right? So the column and row number will be started off with 0. You can see that this is 0, 1, 2, right? Here we're going to, this is 0, 1, 2, 0, 1, 2, and the column will be also starting from 1, 2. All right. Again, the base address is where do you start your array. Okay, so this is what we call the base address. Means that the first elements inside the array is safe. Okay, so this is your base address. You can see, you can hear, based on this one row column, right, is going to be 0, 0, this one, and so on. So basically, okay, the difference is if you do it one line like this, right, that will be your one-dimensional array. But right now this is being pushed down here to the second line and then the other one, so this is considered two-dimensional array. So you can see that that's actually the difference on the list or versus the matrix. Okay, yeah, so this is the first line 618 right here, and then it says the second one, and this is the third one. All right, so that is the difference for the two-dimensional array. So right now, again, to those elements inside the two-dimensional array, right, so you can get also the effective address. For example, if you want to get the effective address, okay, for this column, this element, for example here, you can get it by the formula here. Okay, for example, that the effective address for that particular element 3, sorry, it will be this is the base address plus the size times, you have to do this one first, row times and how many columns for the array plus the column that you want to calculate. So this 2 is the pair for the row and column, whereas this is the total, what is the matrix size columns that you have. So again, the base address is your base address over here. Size is based on the byte size, word or long word, depends on the declaration. For this example, the declaration here is byte, right? And then the row number is this row number, right? This row number is 1, and the column is 2, right? And then the number of columns in matrix, this is what is the size of the matrix. This is 3 times 3, right? So the column and row is 3, so that will be the value. Right, for this case, you can try base address. At the moment you don't have the base address, we can do it later. So base address size times row and columns plus column. So size is 1, right? And then you have the row times n column. Row is 1 times nth column is 3. This is going to be plus. Plus is column that you want to find. Column here is 2. So this is a hexa numbers, so you are not actually changing to decimal, even though it's very small. So this is 3 plus 2, so it's equivalent to 5. Okay, it's 5, right? So yeah, from that 5, right, I mean, you can see the elements, it's actually element number 5. So if this is elements index 0, 1, 2, 3, 4, 5. So this is the index, that element with the index 5 basically, right? So this is the case lah, right? So if you want to find out that one, right, I mean, again, there's an example here. You can see from the example, if you put the base address for the two-dimensional arrays is at 5,000. And then when you want to calculate this one, right, you have the size of the array matrix 3 times 3, for example. This is the one that you want to find the effective address for this particular element, right? So if you calculate, that's the row here. Row is number 2, column is number 101, and the size for the particular declaration for the array is byte. So when you calculate, you have this number 7, all right? So 7 is going to be plus 5,000 base address here, and the answer will be 5,007. So the effective address for this particular array is 5,007. This is the address 5,007. So this is another example. You can try. I mean, for this one, you can look at this all the values here, and then you find out is basically what is the value for the effective address. And then this is the what you call that, the program on how you have how you can want to calculate what would be the elements or being accessed over here based on the address, and given the size and column rows, everything's there. So this is actually a program to do this particular calculations, and at the end you will add this one. It should be the same. This is the base address, and this is going to be the value for here. This is the value here, and then you are going to get the element that you want to access. So the thing is, for a list or one-dimensional array versus two-dimensional array, you still need to use this particular code, right, to access or to write. Eventually the difference will be back to the formula that you want to use, because two-dimensional array and one-dimensional array is going to use a different address to find the effective address. Okay, that's the difference on the two-dimensional address. So it's a two-dimensional array. Sorry, thank you very much.